Hey everyone, welcome to WW2 Stories on YouTube. With advances in modern engineering, even very large vessels are able to remain steady in violent weather thanks to careful design and sophisticated systems that manage forces from wind and waves. And some crafts are even built so they can flip back upright on their own after being turned over by a breaker today. We'll explore the technologies and design principles that make ships far less likely to sink than people might expect when they see towering seas. Asterisk: when a ship moves through the ocean, it is constantly subjected to varying pressures and motions from wind gusts, currents, and waves. So naval architects design vessels with stability in mind from the keel up, which means the ship's stability. System governs how the hull sits in the water and how it responds when external forces try to tilt it. The goal is always to return the vessel to an upright orientation after being disturbed. Asterisk: one common passive measure used to reduce rolling is the bilge keel. These are fixed fin-like projections attached along the lower sides of the hull, and they act as simple hydrodynamic brakes on roll. Typically, they extend for a large portion of the hull's length, and their effectiveness increases with the ship's forward speed, so they most useful when the vessel is underway. Asterisk: another method employs tanks installed across the beam called anti-rolling tanks that use the inertia of shifting water to counteract roll. As the ship heels, water moves inside the tank, absorbing energy and smoothing the motion, which reduces the rate and amplitude of rolling and therefore improves safety and comfort. Asterisk: anti-rolling tanks exist as either passive systems where the water sloshes freely in tuned chambers, or as active systems that include valves and pumps to control the flow. Active tanks are more complex, but can deliver superior roll damping, especially when tuned to the expected sea conditions. Asterisk: a different approach is the fin stabilizer, which uses movable appendages mounted on both sides of the hull that pivot under command to produce forces that oppose rolling. These fins are driven by electro-hydraulic actuators and guided by gyro based control systems, so they react quickly to changes in roll and can be very effective at moderate and high speeds, though their performance drops off at low speeds, typically below about 10 knots or approximately 18 kilometers per hour. Asterisk: for operations in port container ships, often rely on anti-heeling systems, which are servo-controlled mechanisms designed to maintain a level deck while containers are put on or taken off. These systems are not intended to stabilize the ship at sea, but during cargo handling, they automatically transfer ballast water from side to side, under control of sensors and pumps to correct any list and keep the ship safe while loading or unloading. Asterisk: beyond hardware, the overall stability of a vessel depends on the relationship between centers of gravity and buoyancy, so crew and officers must constantly consider weight distribution, fuel, and cargo placement, and any changes to those variables. Because failing to perform accurate stability calculations, whether the ship is loading in port, heading into rough weather, is one of the most frequent contributors to serious maritime incidents. Asterisk: search and rescue vessels are specifically tasked with responding to emergencies at sea, but their missions often place them in the worst possible conditions, where heavy seas and sudden storms make operations hazardous and in extreme cases can threaten to capsize even purpose-built rescue craft, which is why designers have developed lifeboats and rescue craft with self-righting capability. Asterisk: self-righting boats are engineered so that if they invert, they will return to an upright condition on their own, even after a full 180-degree roll. The design philosophy combines a low center of gravity, buoyant upper structures, and systems that automatically protect critical equipment during inversion to allow for reliable recovery in violent sea states. Asterisk: one fundamental design rule is to keep heavy machinery and stores as low as possible in the hull, so that the center of gravity remains low, which creates a strong restoring moment when the hull is displaced. Complementing this, designers make the wheelhouse and control areas light and packed with buoyant materials, so those structures provide the positive buoyancy needed to flip the boat back upright. Asterisk: crew access hatches and all openings are designed to be watertight, so that if the craft rolls, water cannot flood essential compartments. Many boats also use mechanical arrangements such as pendulum weights that, when the vessel inverts, hang into. a position that mechanically closes vents and hatches, helping to preserve dryness inside the hull while the boat rights itself. Asterisk, modern self-righting lifeboats include capsize, detection systems that sense inversion and automatically shut down non-essential systems and protect sensitive electronics and propulsion before the righting event. This reduces the risk of damage and helps ensure that propulsion and navigation systems can be restarted once the boat is upright again, allowing the crew to resume operations quickly. Asterisk, safety procedures on board also matter greatly. Crew are trained to remain seated and fasten harnesses during extreme maneuvers, or when operating in hazardous seas. This prevents injury if a sudden capsize or violent movement occurs and allows the crew to be ready to continue their duties after the vessel regains normal attitude. Asterisk, in addition to mechanical reliability, designers also focus on performance characteristics. So many self-righting boats are capable of rapid acceleration and high maneuverability, enabling quick responses to casualties while maintaining control. In steep waves, these performance traits, combined with protective design, make modern lifeboats far more capable in severe weather than older designs. Asterisk, manufacturers and rescue organizations worldwide build and operate these boats, among them the Royal National Lifeboat Institution (RNLI) in the United Kingdom, which has a long history of refining lifeboat design through operational experience, training, and iterative engineering improvements. Asterisk, that's the end of this video. I hope you found the expanded explanation useful. Please subscribe to WW2 Stories so you don't miss future